Okay, this is Mr. Crane. How you doing? So we have our first period class here today, and we have a Newton's Cradle with us today. So my question is, I said earlier, there's the conservation of energy, conservation of matter, conservation of momentum. What does that mean? What I put
into an object?
Yep. Must come out of that object, right?
Yeah.
So it must conserve. Otherwise, we have to transfer the energy or transform the energy into something else. So here's my question for you. This is Newton's Cradle, called Newton's Cradle because of his three laws of motion. First law of motion is the law of inertia. If something in a straight line is going to continue along that straight line until acted on by some force or that changes direction, it's going to continue on the straight line. Second law of motion is more about forces, mass, and acceleration. If I have a particular mass of an object, I'm going to require some amount of force to accelerate that object a specific amount. The larger the object, the more the mass, the more force, and the more to get it to accelerate. So the third law of motion is every action has an equal and opposite reaction. So my question is if I pull this one ball out of here, what do you guys expect it to do when I let it go? All right, so they're saying if I strike it, they're going to make the other balls. How many balls? If I pull one, how many balls? One. Okay, so they said one. You guys have a prediction? Is it if I pull one out, am I going to get one on the other side? Let's see. So we do. We get one. All right, let's stop the force. What if I pull two?
Then you're probably going to get two.
Oh, I'm going to get two because I have this amount of energy needs to come out the other side, right? So let's watch. Let's see if we can get two come out. I got two. See that middle one staying still? What about three? Do I have three on that side? If I pull three, how am I going to get?
That middle one's going to go to both sides.
All right, so she's saying that middle one's going to go to each side. Let's see if she's right. Can y'all see that one? I used to have a bigger one, but then students messed it up by wrapping it all in pieces and stuff. So I have three. So I have 3, 2, 3, 2, 3, 2, 3, 2, and then finally they all end up coming together. What if I do 2 and 2 like that? What do we think?
They're going to stop. Yeah, they're going to stop.
All right, we said somebody's going to cancel each other out and they're just going to stop. Let's see if their prediction is correct. No, the middle one is absorbing all that energy, and the two on the side, they actually take that energy and transfer it to both, and they both kick out exactly the same as we put it into it. See that? The same amount of energy must be conserved. All right. All right. What if I get 3 and 2?
Then I think that middle ball.
Switch between.
Yeah.
All right. So they're saying this middle ball right here on my hand is going to switch between. Let's see. And it is doing what they said. If you can notice, the middle ball is switching the sides. So it had 3 on one side, 2 on the other. Then it became 3 on the other, 2 on the other. So absolutely. Absolutely. 2?
It's going to do the same thing with the other.
Both are bouncing.
Yeah.
Yeah.
So conservation must be maintained. So the energy in must equal the energy out. So we're going to watch a video in just a little bit of a slightly bigger Newton's Cradle. I think you'll like it.